This lesson involves conjugate pairs and writing equations of polynomials. Alright, the first thing I'm going to do is refresh your memory of the quadratic formula. X equals, we're solving. The quadratic formula solves for x. That's how you start your work. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do is take a look at this quadratic. Since it equals 0, we can solve it. Okay, solve means to find the value of x. To find x equals, it is an equation because of the 0, and it says in the complex number system. You're going to see why in just a second. But what that means is if needed, you could use i's if you need to. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's go ahead and work on that radical. So we have 2 plus or minus the square root of negative 16 all over 2. Okay, now don't be so quick to cancel 2's. Okay, it's not ready to cancel these 2's out just yet. What I'm going to do is work on this radical a little bit. So we have 2 plus or minus. When you see a negative, you have to poke the eye out. We're going to poke an eye out, and what's left is radical 16, which is just a 4. Okay, so step 1, simplify the radical, and now I'm going to give them each their own denominator of 2. The first term gets divided by 2 as well as the second term. All over 2a, they each get the 2. You can see how this is going to help a lot of people cancel. Okay, a lot better here. 1 plus or minus 2i. So here are the two answers in the complex number system, meaning your answers had some i's. What helps a lot of people is to see the two answers. So x equals 1 plus 2i, x equals 1 minus 2i. Two answers. Whenever you get an answer right here with an I, you're going to have plus minus. All right, let's do it again. Let's solve the quadratic in the complex number system. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that your all over divide bar is large enough that everything is on top of it, and your radical sign covers all your calculations there. I've got 1 plus or minus the square root of negative 3. Don't forget to say all over 2. I'm going to work on this radical as my next step. 1 plus or minus. The negative in the radical has to be an I, and the 3 cannot simplify, so it's just radical 3. Okay, make sure that your I is not in the radical. And then I'm going to give them each their own 2. So there you go. The fundamental theorem of algebra says if the polynomial has degree n, and n's more than 1, so you're talking about x to the 5th, x to the 6th, x to the 8th. Okay, if you have degree n, then the polynomial has exactly n complex zeros. Okay, and you could say n complex factors. Okay, so what that means, whatever the power is, if it's the 5th power, okay, starting now, you have to factor it into that many sets of parentheses. I know that yesterday we stopped if it couldn't be factored or if you couldn't use the quadratic formula. But starting now, if you're allowed to use complex, you go all the way to the end, even if you have to use radicals or you have to use imaginaries. Okay, the conjugate pairs theorem, this one's really cool. Okay, if you have a 0 at a plus bi, then it also has one at a minus bi. I think that's evident if we look up here at these examples. Do you see how we got 1 plus 2i? you're automatically going to get 1 at 1 minus 2i, because the 2i came from the radical, and the radical is always plus minus. Okay? So that's called the conjugate pair theorem. I like to call this the buy one, get one free rule. Of course, that's not mathematical. That's just what I say to help myself remember. If you have one complex zero, you're going to have another one. So sometimes books will try to trick you, or they'll give you one, but then you know automatically that there's another one they didn't mention. So it's like they gave you two for free. A polynomial of degree 5. Okay, so what that means, f of x equals a, and then if the degree is 5, there are 5 sets of parentheses. Okay, has zeros 1, 5i, and 1 minus I. Alright, so if you take a look at the buy one, get one free, if they told you 5i, there's automatically one at negative 5i. So hang on a second here. Which part do you change to the opposite? Is it the real part, or is it the imaginary part? It's the imaginary part that's plus minus. Okay, remember this looks like a plus or minus bi, so you change the imaginary part. Here's 1 plus I. Buy one, get one free, there's automatically one at 1 minus I. 1, 2, 3, 4, 5. Those are the 5 zeros. Okay, find the remaining 2 zeros. X equals negative 5i. X equals 1 minus I. Here's the 2 zeros. Now for fun, I do want to fill in our parentheses here. Okay, so this is factored form. Factored form is here at the parentheses. The direction said find the zeros, so technically we're done, but I do want to at least write the parentheses here. So if the 0 is 1, I write x minus 1. If it's 5i, x minus 5i. When it's negative 5i, I write x plus 5i. See how that works? Okay, the next set of parentheses, x minus 1 minus I. Lots of people forget the x here. Because the 0 itself has two things, they forget the x. X minus 1 plus I. Change. Okay, it's good practice. Okay. When it says write the equation of the polynomial, we've been doing this since day 1. Okay, polynomial means many terms. Okay, when it says write the equation of a polynomial, we must multiply it out. Multiply it out. There's lots of people still not multiplying, so make sure you start doing that. Find the polynomial. Okay, so this is one of those examples. We're going to have to multiply it out. It says the degree is 4. So when we're all said and done, I better have an x to the 4th. The leading coefficient is 1. Okay, so there's a lot of things I know already. F of x equals 1. And I need 4 sets of parentheses. The coefficients are real numbers. Oh, here come the zeros. 1. Negative 1. Negative 4 plus I. Oh, they only told us 3 of the zeros. Where's the missing one? Oh, I know. Isn't it buy one, get one free? So if they tell you negative 4 plus I, there's also one at negative 4 minus I. There's the 4th one. Okay, now we can do this. X minus 1. X plus 1. All right, don't forget to put x. Here we go. X, change, plus 4 minus I. Here we go. X plus 4 plus I. Okay, now we have to multiply these together. I am going to show you a trick that's going to make this part here a little bit easier. Okay, first of all, let's definitely multiply these two, because those are conjugates. Those are going to make a nice difference of squares. X squared minus 1. Okay, now what are we going to do down here? Let's look at this very closely because they both have an x plus 4. I'm going to call that A. And now they both have an I. I'm going to call that a B thing. Okay. Now look what this problem is asking us to do. It's asking us to do A minus B times A plus B. Isn't that really easy? A minus B times A plus B? Because doesn't that make A squared minus B squared? Okay, and that's exactly what we're going to do. Okay, I'm going to put some big brackets here just because this might get a little crazy. So we have to take the A thing. Where's my red pen? Take the A thing, which is x plus 4, and square it. Okay, now it says A squared minus B squared. The B is just I, and we're going to square it. Just the I, okay? It was A minus B and A plus B, so the B thing was just the I. A squared minus B squared. So multiplying these is actually going to be really fast and easy. The other option, I don't recommend it, is if we were to take x and then triple distribute. Take the 4 and then triple distribute. Take the negative I and triple distribute. Add all your like terms and pray you don't make a mistake. This is the more elegant way, and I want you to get good at this technique. All right, let's keep going here. We've already got x squared minus 1. I have to multiply x squared plus 4. That quantity squared is x squared plus 8x plus 16. Okay, minus. When I say I squared, you say negative 1. Minus negative 1. Change. So f of x is x squared minus 1 times x squared plus 8x plus 17. Alright, unfortunately I am out of good tricks for you. There is some ways to multiply and be organized, so I will show you that. But we are just going to have to do brute force here. So let's distribute x squared. X squared to all three of them. X to the 4th plus 8x cubed plus 17x squared. Okay, now I'm going to change colors. And what some people like to do when they distribute the next thing is kind of line it up. So now it's negative 1's turn to get distributed. They each need to be the opposite of what they are. Negative x squared, and I'm going to put it here in the x squared column. Minus 8x, I'm going to put that here in the x column. Minus 17 is in the constants column. Now they're all lined up nicely. So f of x equals x to the 4th plus 8x cubed plus 16x squared minus 8x minus 17. So just organizing your work will maybe make things a little bit easier. To graph this polynomial, I'm going to look at a couple of things. I'm going to look at the y-intercept right here for my final answer from the polynomial answer, negative 17. But I'm also going to look at the x-intercepts from the beginning. Two of them are imaginary. Imaginaries are not going to touch the x-axis. So the only place it's going to touch is negative 1 and positive 1. X to the 4th opens up. And since it's odd, they're going to cross. Now there might be like another little curve somewhere. I'm not sure where it is. Okay, so you don't have to add in extra curves. It said make an x to the 4th. So let's just double check that we did indeed make an x to the 4th. Great. Okay, what else do we have? One more, writing a polynomial. Okay, writing a polynomial. So don't forget to multiply things out. All right, here we go. The degree is 4 again. The leading coefficient is 1. Oh, that's nice. So I know I need 4 sets of parentheses. The zeros are 2 with multiplicity of 2. So that's going to be x minus 2 and another x minus 2. buy one, get one free. If one of the zeros is 2 minus I, then we're going to have one at 2 plus I. So let's put the x minus 2 plus I. X minus 2 minus I. Okay, see what all this space is for? It's for multiplying. Alright, let's go ahead and multiply these two right here. These are the same binomial, so that's going to be a perfect square. X squared minus 4x plus 4. And here, I'm going to walk you through that technique one more time. So try to look for something the same. That could be the A thing. So this is A, and this is A. And then here's the B thing. There's the B thing, and there's the B thing. But this parenthesis says A plus B, and this one says A minus B. And how do you multiply those? The answer is going to be A squared minus B squared. Okay, here I go. Let's open some brackets. Let's put all our work in brackets. So the A thing is x minus 2, and you got to square that. But then you have to do minus the B thing squared, and the B thing is only I. Sometimes it's fancier, like 4I. Then you would do 4I times 4I. Okay, here we go. X squared minus 4x plus 4. Here, oh, I just did that problem. X squared minus 4x plus 4 minus, when I say I squared, you say negative 1. Minus a negative plus plus, f of x equals x squared minus 4x plus 4 times x squared minus 4x plus 5. Okay, at this point it's just brute force, but maybe we could try to stay organized and do the technique that I showed you last time. So the first thing I'm going to distribute with my first color is x squared. And that has to go to all three things. So that's x to the 4th minus 4x cubed plus 5x squared. The next thing I'm going to distribute with my second color here is negative 4x. So that has to get distributed all three times. And that's going to make negative 4x squared. Negative times negative is plus 16. Oh, this is a cube. Oh, no. Minus 4x cubed goes here. This is going to be plus 16x squared minus 20x. The last thing I'll distribute is a 4 3 times plus 4x squared minus 16x plus 20. Okay, now they're all lined up nicely, so I can go ahead and write the final polynomial. X to the 4th minus 8x cubed plus 25x squared minus 36x plus 20. The last thing we need to do here is graph this polynomial. The y-intercept is 20. Let's talk about the end behavior for a 4th. So we're going to have arrows going up, up. The x-intercepts, 2 is an x-intercept, but the imaginary ones are not going to touch the x-axis, so the only x-intercept is 2. But wait a minute, it appeared twice. So when the multiplicity is even, what are we going to do there? We're going to brush. This is definitely going to brush. It's got to cross here. Should I touch the x-axis? No, no, no. Go up, 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 and there is the polynomial graph. Good job.